In 2003, Google had a scaling problem that had nothing to do with servers. Their services were growing faster than they could hire operations staff. The traditional model, developers build it, ops team runs it, everyone pages at 3 a.m., was breaking down. So Ben Trainersloss tried something different. He staffed the operations team with software engineers and told them to treat operations as a software problem. That decision created site reliability engineering, and today we're going to break down the principles that make it work. The first principle is deceptively simple: operations is a software problem. Traditional ops teams write runbooks, documents that tell humans what to do when something breaks. SRE teams write code. Instead of a runbook that says, when disk usage hits 90%, SSH into the server and clean up old logs, an SRE writes a daemon that monitors disk usage and rotates logs automatically. This matters because human-driven operations scales linearly. More services means more people. But software-driven operations scales sublinearly. You write the automation once and it handles the next 100 instances too. Google enforces this with the 50% rule. SREs should spend no more than half their time on operational toil, manual, repetitive work that scales linearly with service growth. The other half goes to engineering projects that reduce future toil. When toil exceeds 50%, the team pushes back on new responsibilities. They stop onboarding services until automation brings the ratio down. Without this hard cap, every SRE team eventually becomes a traditional ops team with a better job title. The second principle is the one that surprises most people: 100% reliability is the wrong target. Think about it from the user's perspective. They're accessing your service through their home Wi-Fi, which drops packets. Through DNS, which occasionally hiccups. Through their browser, which has its own bugs. Every link in that chain introduces failure. Your users literally cannot perceive the difference between 99.99% and 100% uptime because the rest of their stack is noisier than that gap. So instead of chasing the last fraction of reliability, SRE defines an acceptable failure rate. If your SLO, your service level objective, is 99.95% availability, then 0.05% is your error budget. Over a 30-day window with 10 million requests, that's 5,000 requests that are allowed to fail. Here's where it gets powerful. That budget is a shared resource between product and reliability. When the budget is healthy, say above 75% remaining, ship fast. Deploy weekly. Run experiments. When the budget drops below 50%, slow down. Require extra review. Below 25%? Full change freeze. Only reliability improvements get deployed. This eliminates the classic tension between product managers who want features and SREs who want stability. Both teams are looking at the same number. Product wants to ship a risky feature? Fine, but it costs error budget. If there's budget remaining, go for it. If not, invest in reliability first. The math resolves the argument. The third principle is blameless postmortems, and the word blameless is doing more work than you think. This isn't about being nice to people who caused outages. It's about incentive design. If engineers fear punishment for honest accounts of what went wrong, they'll write sanitized postmortems. They'll describe symptoms without revealing the actual chain of decisions that led to the failure. And you'll miss the real root causes. A good postmortem focuses on contributing factors, not individual blame. The deploy that caused an outage is never the whole story. Why did the deploy make it past code review? Why didn't the canary catch it? Why was the alerting delayed? Each contributing factor becomes an action item that prevents a class of future incidents. One outage, investigated properly, can prevent dozens of future ones. Now if you're coming from a security background, you might be wondering why an SRE series matters to you. The answer is that SRE and security engineering are structurally identical disciplines. Both are trying to maintain system properties, reliability and confidentiality respectively, against constant pressure to ship fast. The error budget model works for security. Define an SLO like 95% of critical vulnerabilities patched within 48 hours, track your budget, enforce change freezes when you're behind. The monitoring infrastructure SREs build is the same infrastructure security teams need for detection and response. The incident management practices transfer directly. Learning SRE gives you the operational backbone that all security work depends on. Let me leave you with the 5 SRE tenets that matter most in daily practice. First, operations is a software problem, write code to solve operational pain. Second, manage by service level objectives, not by gut feeling. Third, toil is toxic and must be actively reduced. Fourth, automate this year's job away so next year you can tackle harder problems. And fifth, move fast by reducing the cost of failure through canary deploys, rollbacks, and feature flags. Tomorrow we'll dig into SLIs, SLOs, and SLAs, the measurement layer that makes all of this quantifiable. Day 3 covers error budget policies in depth. If you're following the 60-day production engineering challenge, subscribe so you don't miss the rest of the series.